Hello, everyone. We are working on statistical methods for rates and proportions, Chapter 3, Assessing Significance in a Fourfold Table. We're working through section 3.1. So we're going to move along with the same example that we had where we have people who have characteristic A present or absent, characteristic B present or absent. And we set up our data set. And then we want to make sure that we relevel our factors so that it defaults to comparing to present versus absent versus automatically just alphabetizing the values. So by doing this, when I print T, I get the table similar to what we saw in the book where we see present on top and then absent, present first and then absent versus flip-flop. Okay. In our book, table 3.5, we can see that it's changed everything to be the joint proportions of A and B versus the number observed in A and B. So from a previous video, we talked about this prop.table that will turn everything to the joint proportion. So we rename this P.T and this is giving us the joint proportions. And when we look at that, we have the same values as in table 3.5, 0.075, 0.675, 0.50, and 0.20. So the interpretation is slightly different. We have 15 people in our study who have characteristic A present and characteristic B present. However, we have 7.5% of our sample being characteristic A present and characteristic B present. So P.T is telling us the joint proportions within each of the cells, whereas T is giving us the number of people within each cell. All right, so in method 1, we're really talking about a situation where we're collecting cross-sectional data or more of just like a naturalistic model, or if we had more than 2 categories, you could call this multinomial sampling. And if we were to do this by hand, remember we could set up all the cells of T being the number in each cell, right? The number of people in the 1-1 cell, the number of people in the 1-2 cell. So we're using the square brackets to do this. And remember that we calculated the row sums to get the marginal N1 dot, N2 dots. And we also get the N.1s and N.2s for the column sums. And the N.dot was the overall sum of the whole table. So we did that in the last video. But now we're going to talk about P11, P12, P21, and P22. We're also going to get PI dots, which are the row proportions. We're going to talk about the P dot J's, which are the column proportions. So we're going to run through P11 all the way to P22, and we're picking this off of our proportion table now, P dot T. And then to get the row proportions, we're going to look at the sums. So here we have P1 dot is 0.75 and P2 dot is 0.25, right, for characteristic A. And then if we want to get P dot J, we get 0.125 and 0.875. Those are the marginal proportions of characteristic B. And we can save those as P dot 1 and P dot 2. And I've already defined N dot dot, so we don't need to run that line again. Apologize that was there twice. So for the chi-square test statistic that is given in equation 3.3 on page 53 of our book, right? It does the summation over I and J of all of these things. So what I did here is I'm initializing a matrix X. So when I do this, I'm saying, give me a matrix in which the number of rows is equal to the number of rows in my table, and the number of columns is equal to the number of columns in my table. So when I run this through, I can look at X, right? And all the values are missing right now because I haven't told it what each of those values are. And I'm using this just as placeholders to be able to calculate what's given in 3.3. So if you look at 3.3, it essentially gives you each of these pieces. And then we're going to be able to sum them all up at the end of the day and multiply by n dot dot. So I'm doing a for loop over I and a for loop over j. This will be helpful if you ever have more than 2 categories to get this. And so I get all of the individual pieces. You can double check these numbers with 3.4 in your book with that example. Each of those terms should be in there. And then to get our chi-square test statistic, we're going to do n dot dot times the sum of each of those pieces. So when I get the test statistic, it's exactly what I thought it would be. It's 2.58 once again. And just as a reminder from the last video, this is how we calculated it using all the sample sizes. We still get 2.58. And as a reminder, we can get the p-value by using the p chi-square function in R. We still have to give it the degrees of freedom, which is the number of rows in T minus 1 and the number of columns of T minus 1. And we can feed it the chi-square test statistic, whether you use the new one or the old one, it doesn't matter because we got the same exact value. So remember that our p-value is 0.1085. But once again, we could just use the shortcut and we get the same exact values. So really this is an exercise of making sure you know how to set up the equations and run through it. But at the end of the day, the shortcut will give you the same exact thing. But it's good to get the practice to understand what are the formulas doing, why are they doing that, does everything make sense? And so hopefully you'll have some code set up which does that. And then in practice, you're probably just going to use the shortcut. Awesome. I hope you learned something today and I will see you on the next video.